Okay, this is day 9 of Unit 4, and we started today with a warm-up. So pause the video, take a moment to complete the warm-up, and then check your answers. So first I will work on this first one. So I'm rewriting in vertex form. So I'm taking a 2 out, factoring out a 2, left with x squared minus 5 halves x. And then I have plus 6. So I'm going to take half of 5 halves, or in other words, 5 halves, negative 5 halves times 1 half, which gives me negative 5/4. I'm going to square that, which gives me 25/16. So I'm adding 25/16. But it's actually 25/16 times 2 that I'm randomly adding. So I'm going to simplify that. That's 25/8 that I need to subtract. So I have y equals 2 times, remember I had minus 5/4, so x minus 5/4 of the quantity squared. And then I'm getting 6 into eighths, so 6 is 48/8. 48/8 minus 25/8. So I did 6 into eighths, which is 48/8. And now I'm subtracting 48 minus 25, which gives me 23/8 positive. So vertex form is y equals 2 times the quantity x minus 5/4 squared plus 23/8. Okay, that's number 1. Next, 510 is the exponent, which I have to divide by 4, remember, because I'm trying to figure out which of the 4 options this is going to be. So 4 goes into 5 one time. Subtract gives me 1, bring down the 11. 4 times 2 is 8. Subtract gives me 3, bring down the 0. 7 times 4 is 28. Subtract gives me a remainder of 2. So the R, the remainder is 2. That's really what I care about. I don't really care about the 127. All that tells me is that we went through the cycle of 4 different options 127 times. Where we ended up in the next cycle is at I squared because of the 2. So I to the 510 is equal to I squared, which is equal to negative 1. Next, we're going to multiply these two binomials. We have 2 plus 3i, and we have 5 minus 2i. So 5 times 2 is 10. 5 times 3i, 15i. Negative 2i times 2 is negative 4i, and negative 2i times 3i is negative 6i squared. So we have 10. We have 15i minus 4i, which is 11i. And we have negative 6i squared, which means negative 6 times negative 1, which is positive 6. So plus 6. 10 plus 6 is 16. 16 plus 11i is my final answer in complex form with the real part and the imaginary part second. Real part first, imaginary part second. Okay. So today we looked at some more simplifying of complex and imaginary numbers, but today we looked at some applications, so solving quadratic equations that have real or complex solutions. So first, this one, go ahead and put that in your notes. We're going to solve. So I need to subtract 5. I immediately am thinking square roots technique here because of the fact there's no x. Divide by 2. X squared equals negative 18. Square root of each side, absolute value of x, equals the square root of negative 18 is 3i root 2. And x is equal to plus or minus 3i root 2. So remember what that means. 3i root 2 and negative 3i root 2. If I substitute back in for x, square and multiply by 2 and add 5, I would get negative 31. So these are values that solve this equation. Even though they're not part of the real number system, they are values that will solve the equation. Next, this problem is in your packet on page 13. It's problem number 19. Now this problem was previously assigned, but it was assigned before I explained how to simplify imaginary numbers. So you should see that this problem hopefully is already done, but you had to stop when you got to a square root of a negative. So now we're going to finish the problem because you didn't know how to simplify. So I'm supposed to complete the square. I'm going to take 19 halves and I'm going to square that, which gives me 361 fourths. So I have v squared plus 19v plus 361 fourths. And I'm going to add 95, and that I'm going to skip a little space, that equals 0. I randomly added 361 fourths, which means I'm subtracting that, fourths. And then I'm going to rewrite this as v plus 19 halves, the quantity squared. And I'm going to figure out what 95 in fourths is. So 95 over 1 is, I think, 380 fourths. So I'm going to do 380 fourths minus 361 fourths. And when I do that, I'm getting 19 fourths. And that equals 0. So now I'm going to subtract 19 fourths from both sides. And now I'm ready to take the square root of each side. The square root of something squared is the absolute value. And the square root of negative 19 gives me the square root of 19. And the square root of 4 is 2, and there's an I because of the negative. So then v plus 19 halves is equal to plus or minus the square root of 19 halves I. So I'm going to subtract 19 halves. And I can either leave it that way or recognize that 2 is in both denominators, so just make one big fraction. Negative 19 plus or minus either I root 19 or root 19I. Either's fine as long as you make sure the I is clearly not underneath the square root. And that's all over 2. And those are my final answers for V. Okay. And like I said, you probably previously when you did the problem got it up to about here, but you didn't really know how to simplify square root of a negative. Okay, next. So this one we're going to solve using the quadratic formula. I am going to use the quadratic formula, but I'm noticing there's a GCF, so there's no reason I can't factor out the GCF first. That way I'm dealing with smaller numbers when I solve using the quadratic formula. So might as well. So I factored out the 2. So now using zero product property, either 2 equals 0, which we know it doesn't, or x squared plus 3x plus 4 equals 0. So now we have a new quadratic equation that we're going to solve. And again, the only real purpose to that, this 2 doesn't really affect our answer. It just makes it easier for us to solve using the quadratic formula because our numbers are now smaller. So we know x equals negative b, so the opposite of 3, which is negative 3, plus or minus the square root of b squared, which is 3 squared, minus 4 times a, which is 1, times c, which is 4, and that's all over 2 times a, which is 1. So simplifying, x equals negative 3 plus or minus the square root. 3 squared is 9. Negative 4 times 1 times 4 is negative 16, and that's all over 2 times 1, which is 2. So x is equal to negative 3 plus or minus the square root of 9 minus 16 is negative 7, and that's all over 2. So simplifying, negative 3 plus or minus, I know the square root of negative 7 simplifies to I root 7, and that's all over 2. I'm looking at the 3 and the 1, and I see no GCF except for 1, so I know I can't simplify that further. X equals negative 3 plus or minus I root 7 all over 2 are my final answers for x. Next, so this question asks for us to figure out the values that p could be so that this quadratic equation is going to have two real solutions. So in order to answer that, I'm going to actually go back to the last problem for a moment. In the last problem, our solutions were imaginary, or they actually were complex because they had an imaginary part and a real part, but they were imaginary or complex, you can think of. Okay, that was because if I'm looking back through the quadratic formula, the minute I knew that we were going to have imaginary numbers was really right here. Okay, this step here, because that was when we realized we had a square root of a negative. Okay, so if we think about it, the part of the quadratic formula, if I'm looking at this whole initial substitution into the quadratic formula, the whole quadratic formula doesn't cause the equation to have imaginary or complex solutions. Just this piece, just the piece that's underneath the square root. Similarly, if that was positive there, like what we're used to solving with and getting a square root of a positive number, then we'd have real solutions. Okay, so we know that really that piece right there, the part that's underneath the quadratic formula, underneath the square root, that's the piece that causes us to have real or imaginary solutions. So having said that, now we'll come back to this one. So if I look at the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2a. Really, the piece that I care about in relationship to this problem is this piece, the piece that's underneath the square root. That piece, that b squared minus 4ac. Notice I didn't include the square root, just the part that's under it. That is called the discriminant, D-I-S-C-R-I-M-I-N-A-N-T, discriminant. And the discriminant is what causes us to have either real or imaginary solutions. So if that piece, the discriminant, is positive, we already talked about, that's when we know we're going to have two real solutions. So let's put that in your notes. If b squared minus 4ac, or the discriminant, is greater than 0 or positive, then there will be two real solutions. On the other hand, if the discriminant is less than 0, or in other words negative, then that's when, like the previous problem, that's when we'll have two imaginary. And again, sometimes they won't be just imaginary, they'll actually be complex because there'll be a real part and a imaginary part together. So complex solutions. Lastly, sometimes we'll have b squared minus 4ac, or in other words, the discriminant, we'll have it equaling 0. Okay, and let's think about that a moment. So I'm going to go back up to the formula. If I'm in the process of solving and I'm adding the square root of 0, because we said the discriminant's 0, well, the square root of 0 is 0. So if I'm adding 0, then I go ahead and subtract 0. Adding 0 and subtracting 0 is going to give me the same amount. So I'm only going to get one real solution. So there'll be one real solution. Okay, so those are my three options. So those you'll need in your notes, and you'll need to know them. For this particular problem, though, we want the discriminant to be greater than 0 because we want two real solutions. So all I have to do now is substitute in the a, b, and c values and solve for my variable p. So b in this equation is p minus 4 times a, which is 2, times c, which is 6, and that should be greater than 0. So solving, simplifying, p squared, negative 4 times 2 is negative 8 times 6 is negative 48. That should be greater than 0. So p squared should be greater than 48, taking the square root of each side. P squared, the square root of p squared is the absolute value of p, and that's greater than, I'm going to go ahead and simplify, root 48. That's 4 root 3. And then remember, you can't just take off the absolute value and say it's greater than plus or minus 4 root 3. That would be incorrect. This is an absolute value inequality. So remember, we make two separate inequalities. P greater than 4 root 3 is the first one. The other is P is less than negative 4 root 3. And the word, when it's an absolute value greater, is or. So P could either be greater than 4 root 3 or less than negative 4 root 3 in order to make this quadratic equation have two real solutions. So if P is less than 4 root 3 or it's greater than negative 4 root 3, then the solutions are either going to be, there's either going to be one real or two imaginary. Okay, but if it's greater than 4 root 3 or less than negative 4 root 3, then we're going to have two real solutions. So let's try one more that's similar. So this time it says two imaginary solutions. So we're going to take the discriminant and we're going to set it less than 0 because two imaginary. So I'm going to set b squared is s minus 4 times a is 3 times c is 2. And that's going to be less than 0. So s squared, negative 4 times 3 is negative 12 times 2 is negative 24. So solving for s squared is less than 24, square root of each side. Absolute value of s is less than, I'm going to go ahead and simplify, root 24. So that's 2 root 6. And then to get rid of the absolute value, again, choose separate inequalities. S is less than 2 root 6. This is a less than absolute value, so that's and S is greater than negative 2 root 6. So I can write it that way as two separate inequalities with the word and. Or remember, when it's an and, you can put the variable in the middle and then the smaller number on the left and the larger number on the right. And that is another way of writing the two separate inequalities. Okay, so either is fine. They both read the same way. They both have the same, they both represent the same values for s. Okay, so if s is in between those values, then we will have, in this case, two imaginary solutions, any number in between those. Again, if you had something bigger than 2 root 6 or something smaller than negative 2 root 6, then you would have either one real or two reals, but you wouldn't then have two imaginary. Okay, so that's how you do that type of a problem. So homework for next class is pages 19 through 21. Remember, please stay on top of your assignments. Get that assignment done for the next class. Don't fall behind. This is a tough unit, and you need to stay on top of your assignments. Next week, you'll have a quiz, the second quiz for the unit. So go ahead and work on those problems for next class.